Welcome back. This is lesson 3.8, ordered pair relationships. You're going to read from the vocabulary for chapter 3. I will be able to identify different relationships on the coordinate plane. I will be able to graph the reflection of any point across any axis. Okay, our vocabulary for this lesson: horizontal, that's straight from left to right. Vertical means straight up and down. Coordinate plane is this lovely thing where we have two number lines that intersect at 0, 0. The x-axis is the horizontal axis. The y-axis is the vertical axis, so we can go ahead and write those on there. So we have our x-axis here and our y-axis here. Okay, the origin is right here at the center where they intersect. Ordered pair are these points, the x-coordinate and the y-coordinate. So we have our x that tells us left and right, our y-coordinate that tells us up or down. Okay, these are our new ones: quadrant, reflection, and line of symmetry. So pull out page 41 and let's finish filling this out. The quadrant are the four sections created by the axes. Axes is how you should say that. So you see these four sections, you divide it into fourths. Okay, we have four quadrants. Quadrant 1 is the one that you're used to graphing in, where everything is positive. So right here, you have everything on the x-axis is positive. Everything on the y-axis in this place is positive as well. Okay, quadrant 2, so it kind of makes a C as we go around. So 1, 2, so quadrant 2. Now looking at this one, everything in here, your x is a negative number. All your y values are positive. And they like to write these in Roman numerals. So quadrant 3, everything here is negative. This is negative land. We have a negative x. We also have negative y. So I like to think of quadrant 3 as the underworld. Everything is negative here. Okay, quadrant 4. 2 and 4 are the ones that people confuse the most. Okay, quadrant 4, we have the x is positive and the y is negative. So see how the y values here are negative? So like this point, positive 8, negative 4, it's in quadrant 4. Okay, next one, the line of symmetry. If you fold the picture or graph down this line, it will be a perfect mirror image on each side. Okay, now a reflection. So in math is when a point is the same distance away from 0. Oh, sorry, from the line of symmetry. So it's when a point is the same distance away from the line of symmetry, but in the opposite direction. Okay, make sure you got those filled out. I'm going to go back to page 49. So we're going to fill out the quadrant stuff here again. So we have quadrant 1, where everything is positive. This is our favorite place to graph because it's where we learned to graph. Remember the L graph that you used to do? We just wouldn't show all the other quadrants. So quadrant 1, positive, positive. Quadrant 2. Quadrant 2, x is negative, but y is positive. Quadrant 3 is the land of the underworld. Everything is negative here. Negative x, negative y. Quadrant 4, This is where x is positive and y is negative. Okay, so here it says, name the quadrant where each point is located. Okay, we have a -3, -5. So if I were to graph this, -3, -5 would be located in quadrant 3. I'm just going to write 3. Now, without having to graph it like I did, how could I know that this is in 3? Well, look at both my numbers. They're both negative. So that's my clue that this is quadrant 3. Okay, 2 is positive, so that means x is positive, y is negative. Without having to graph the full point, I can know that this would be in quadrant 4. Because, well, x is positive, y is negative. +7, +4. +7 would be 7 this way, 4 up. I'm going to end up in quadrant 1. Now this, I want you to pay attention to. 0 is neither positive nor negative. Because of that, that tells me I'm not actually in a quadrant. 0, -3, if I were to graph that, I go 0 on the x, -3 on the y, it would be right here. What quadrant am I in? It's like I'm sitting on the fence. Technically, I'm not in any quadrant. I'm on the y-axis. So it's not in a quadrant, it's on the axis. -2, 0, -2, 0. That 0 is a clue. I'm on an axis again. This time, I'm on the x-axis. Okay, so you can always graph it to decide what quadrant you're in, but if you can use those clues just looking at the ordered pairs, that could make it even easier on you if you can memorize what goes where. So here it says, using the map at the right, identify the ordered pair and place them on the map. List the ordered pair for the library. Okay, the library is located at -1, +3. Make sure you put the parentheses around it. That's how we know it's an ordered pair. Now it says, Kelly's house is a reflection of the library across the x-axis. Okay, remember the definition for a reflection? It's the same distance away from your line of symmetry, but in the opposite direction. So Kelly's house would be 1, 2, 3 units away from the x-axis, but in the opposite direction. So I'm going to go from here, and I'm going to go 3 in the opposite direction. So 1, 2, 3. Make a dot right here. Name that point K. That's where Kelly's house is located. What are the coordinates of it? So name the point K. That would be at -1. I still am -1 this way, but now I'm at -3. So -1, -3. So look what happened to my points. When I jumped across the x-axis, my y value changed. That's because what's on the opposite side of the x-axis? The y changed. We went from up to down. Okay, list the ordered pair for the skate park. The skate park is located at -3, 0. The soda spot is a reflection of the skate park across the y-axis. So from here, I'm going to go across the y-axis and name that point S. So across the y-axis, it's 1, 2, 3 units away. So I'm going to stay same horizontal or vertically, but I'm going horizontal, the opposite direction 3. So 1, 2, 3 units. Label that S. That is located at 0. Not 0. X first. 3, 0. Now look how that changed. When I crossed the y-axis, my x value changed in sign. Okay, list the ordered pair for the school. The school is located at 4, +2, +4, +2. Okay, it says the lake is a reflection of the school across the x-axis and then across the y. y-axis, it's 2 units away from the x-axis. So I'm going to go 2 units away from the x-axis here. However, that spot right there is just part of it. It says then across the y-axis. So I've reflected across the x-axis. Now I'm going to reflect this one. This is 4 units away from the y-axis. So here I'm going to go 4 units across the y-axis, and this is the location of the lake. Name that point L. So what are the coordinates of this point? Well, I'm at -4, -2. So when I reflected across both axes, look what happened. Both of my values changed. So what do you notice about the coordinates when you reflect across the x-axis? So when we went across the x-axis, the x value stayed the same. The x-coordinate stays the same. But the y-coordinate is opposite in sign. So all that changed was it changed vertically. Okay, what do you notice about the coordinates when you reflect across the y-axis? So when we cross the y-axis, the y-coordinate stayed the same. But the x-coordinate changed in sign. Okay, it was a horizontal change. So without graphing, what would the coordinates be of the point 4, -5 if reflected across the y-axis? So if I'm going across the y-axis, that means my x is changing. I'm going to be jumping horizontally. So I'm going to keep the y the same, so it's still going to be -5, but I know my x is going to be opposite in sign. So it would be -4, -5. Okay, rate yourself on this concept, 0, 1, 2, 3, or 4. Take a picture and turn it in on your passport.